Well, I'll start saying good afternoon to everybody. Thank you for joining us in this event on transforming the water sector from linear to circular and resilient. My name is Ana Delgado, and I'm a water specialist and a team member of the Water and Circular Economy and Resilience Initiative by the World Bank, which we will present also today. And this session will mainly have three presentations. First, Carlo Mattei, Water and Sanitation Specialist at the World Bank, will show how the circular economy principles can be applied in the water sector. And we'll also present the Wiser online tool that we have prepared to assess if your project is circular and resilient. And then we will have two real examples. First, the case of Senegal, presented by Clementine Stipp, water sector specialist at the World Bank. And then Daniel Nolasco, which he has many titles, but one of them is Vice President of the International Water Association, will present the case of Sao Paulo. And finally, Diego Rodriguez, lead water economist at the World Bank, will finish with closing remarks. And we want a very interactive session, so hopefully we'll have a lot of time for Q&A. So have your questions ready. And now we wanted to start with a short interactive poll to get to know you, the audience. So if you go to, you can use the QR code in the screen. I think it should work with your phone. I tried before and it works from the screen. Or if not, you can go to menti.com and use this code that you see here, 25602999. And then, yeah, if you're logged in, just press the thumbs up so we know that you're connected. I'll wait a little bit to give time to everybody. We have now 5 people. Okay. 10 people. I don't know how many people we have. I cannot see it. Well, you can still join, so I'll start moving because I'm not sure how many people we have. We have already 12 now, 14 connected. And at the top, you can always see the code, so you can keep joining if you still didn't manage. Let's see. Okay, so just one reminder, because if you're using it on your phone, at the end, sometimes it doesn't show submit, so you need to scroll down and make sure to click submit so we can see it here in the screen. Okay, next question. Well, we start now. So the first question is, where are you connecting from? And if you're in Stockholm for the Water Week, please choose where you are actually from or you usually live. It's a bit hard with this map in the phone, but at least we get an idea more or less where people are located. I'll give you a bit of time. I'm being told we have 40 people connected, so let's give a bit of time. So it's nice to see many people from North and South America and also Europe. Okay, I only see 18 replies, but I'll move to the next question. And then age group. Let's see, we have young professionals, mid-career. And so look up at the screen and then you'll see the replies from the rest of the guests. Okay, so many young professionals. It's good. And next question, in the type of organization that you work. Wait a little bit. No one from academia. Surprising. And now I have private sector, which is also good for the discussion at the end on financing. Then which sector do you work? I guess many of us from the water sector, but maybe you can be a bit more specific and see which words come up. And I think at the end you can receive also the results. So also from our sectors, food, urban, oh, nice mix. Beauty industry, interesting. Okay, next question. If there's any countries that you usually work or that you're currently working. Okay, so I would also mix hard to read when it's moving, but Kenya seems repeated. So, okay, nice word map. Okay, next question. Why are you attending this session? Also good to see that many of you are involved in circular economy projects. Nice distribution. Okay, next question. What would you say is your current knowledge on circular economy, specifically in water? Oh, we have an expert. Oh, and I hear from you. Okay, interesting. So most of you have basic knowledge, right? And then kind of what is the main goal of circular economy? According to its definitions, it's kind of more a quiz. There's only one correct answer, supposedly. I think like we see the screen. Okay. Yeah, so here, yeah, many people, most of people got it right. Like some people think it's only recycle, but as we'll see in the presentation, it's not only recycle. That's only one small part of circular economy. And then this is specifically a question about the water sector. So which of these actions you would say are aligned with circular economy principles in the water sector specifically? If it makes lots of it, I would say from my point of view, it's all of them except maybe of investing in the art and state-of-the-art technologies. It doesn't necessarily, you don't necessarily need to do that. But all the other ones, I would say, yeah, would be part of circular economy. Okay, and then the last question, just to get to know what do you think about circular economy principles? And yeah, if you strongly disagree or agree with these statements regarding circular economy principles. We should have done this now and at the end of the presentation to see if we make you change your mind. Okay, so you think as we think, I think. I would agree with this. Okay, and this is the last question. I'll give 2 more seconds. And yeah, so thank you so much. Now we know each other a little bit. And then I'll stop sharing my screen and I'll pass it on to Carlo, which will continue presenting the WISER initiative and the WISER framework. You can go ahead, Carlo.
Okay, can you guys hear me?
Yes, it works.
Yep. Yeah, thanks, Anna, for the introduction. And again, good morning, good afternoon, good evening, everybody. It's great to see people connected from everywhere in the world. Today, I'll talk about the framework, which is Water and Circular Economy and Resilience. We call it the WISER framework. And I think it's realigned to the topic of the Water Week, which is prepare for a wise future in water. I'm Carlo Amadei, and I'm a water specialist at the World Bank. Let's see what we have for today. I see many people here are really familiar, but I just then breeze through what is circular economy and how we can apply circular economy to the water sector. And finally, I will conclude with some wiser activities that we're carrying out at the World Bank. So what is circular economy? I always like to start from what are the main objectives of circular economy, and then from there we can derive actions. But generally, like we have three main objectives, which are regenerate natural system, design out waste and pollution, and keep material and products in use. With the idea that circular economy really can boost economic, natural, and social capital. As Anna said showed in the results, how we can achieve circularity, we really need to decouple the economic activity from the consumption of finite resources and environmental degradation. We should aim to restore it and regenerate ecosystem, eliminate waste and efficiencies from our processes, and really we need to get rid of this idea of end-of-life concept and replace it with the idea of restoration. However, natural water in nature is really circular, but we sort of force it in our system in a really linear path. So we abstract water, we treat it differently depending on the use, we distribute it, we use it, and then we just discharge it. And in best case of scenario, we treat it, and then we discharge it. But we need to go back and we need to be inspired by the circularity of the water cycle in nature and by including elements of resilience and inclusivity, we came up with the WISER framework. Again, here it looks like a lot of information. Don't worry, I'll guide you through this framework. But I just wanted to say that this framework could look theoretical, but actually it's really built bottom up with experience and with cases in the developing world, as we will see as well with the presentation from Clem and Danielle. But just to guide you a bit through this framework, we can see the outer circle. These are the main objectives. We have main outcome. The main outcome is deliver resilient and inclusive services. We have to design out waste and pollution and preserve a regenerated natural system. This is again aligned with the main circular economy principles. And in blue, we have actions to achieve those. For instance, to design out waste and pollution, we can recover resources. And the inside, we just have, again, this idea of going back to circularity, being inspired by nature. So nature provides the resources, not just water. We supply this water and the resources to the user, city, industry, agriculture. Then we can recover directly some of these resources, or we just pump it back into the ecosystem and we restore as well the ecosystem. In the next slide, I'm just going to dive a bit more into these actions by offering some cases that we documented around the world. So, for instance, outcome number one is deliver resilience and inclusive services. What we mean by resilience, there are many definitions out there, but you can think of like a range of options, scenario that a system can tolerate. And for this reason, we have to invest and plan differently to what we're doing right now. And we need to prepare for climate and non-climate uncertainties. And how we do that? I think, and here we dive into the action, we have to diversify supply sources. This is not just diversify the supply sources, but also means to restore and protect the supply sources that we are currently using and having more of an integrated approach. And here there is the case of Chennai. We are actually now supporting Chennai, but also we documented a case in which they're trying to diversify their water supply sources by integrating, for instance, reuse of wastewater, indirect potable reuse. So they have a range of options. Another thing that we'll see right after my presentation is to maximize the use of infrastructure. We have a beautiful case from São Paulo, so I will not say much about this. And for outcome number 2, we have to design out waste and pollution. And so this means like recover resources from the water, but since we interact with the water resources, it's not just water we're recovering nutrients, we're recovering energy. And again, here we will see a case documented by Clem on Dakar in Senegal. One other important thing of designing out waste and pollution is to remove inefficiencies. So we have to reduce non-revenue water. We need to improve energy efficiencies. And here we have really interesting cases from Indonesia. And by the way, here you can see all the links. And we're happy to share the slides afterwards, where here in the case of Indonesia, I think what is more interesting are the payback time that are really short, 3 to 5 years max. So things that make sense from a financial perspective. Of course, we have to be, as I said, energy efficient and use renewable energy. There are many cases on how we can integrate and implement renewable energy such as solar into wastewater and water treatment plant. And finally, outcome number 3, we have to preserve and regenerate natural system. I think this is really embedded with nature-based solutions. And could be the idea of sponge cities to increase the absorption of water and then reduce the flood risk. It's really important to do upstream reforestation. This could increase the water quality of rivers, reduce the turbidity, and thus reduce also the cost, the operation and maintenance cost of water treatment plants that they rely on river water for supplying water. In terms of wastewater, we can construct wetlands. And what we've seen, what we documented, is also that you can really recover degraded wetlands, degraded watersheds and land through the use of, through the implementation of wastewater technologies. And finally, we can have specific solutions for buildings. Again, this is something that we documented bottom up. There are many cases. Possibly this map is not updated, but as you can see, all the cases that we documented are based mainly in low and middle income country. And this sort of like aligns to what we do at the World Bank. So we try to, for sure, increase the knowledge to inform the policy dialogue. But at the end of the day, what we're doing is to offer operational support. We want to offer support to our clients to implement, in this case, circular solution in the water sector. And one of the things that we're really excited about, and I will invite you just to scan this code. We came up with a quick, wiser assessment tool. Here you can see there is going to be like a short questionnaire, and basically it's going to lead you on the things that you're doing well in terms of circular economy and things that you could improve. And at the end of the questionnaire, you will receive an email with a detailed report, and you can share this report to your colleagues. And the other things that we're really excited about is we are doing a guidelines note to quantify economical and financial benefit of circular economy. I've seen in some of the answers that people think actually that circular economy principles are really expensive, but actually, if we're considering all the externalities, they're more economical beneficial than traditional and linear approaches. So I just want to conclude here. I think the framework, and again, I invite you to read more. It can be a bit overwhelming, but you don't have to do everything, right? Just offers a long-term vision, and you can just start and helps to identify opportunities. And you can start from those and try that, pilot those, and see how it goes. And we can really think that this one and these solutions, low and middle income country can leapfrog. So if there are not infrastructure there, they can just leapfrog, skip the linear traditional system and adopt the circular one. And again, circularity is not an aim. Circularity should be a mean, at the end of the day, an approach to reach your objective. That should be like universal access, sustainability, equity. And with this, I would like to conclude. And here, just like underline a few important links where there are like other resources that you guys can check it out. And with that, I'll pass it back to Anna.
Thank you, Carlo, for the presentation. As Carlo said, you can find all this information in our website. We have the report on Wiser, also a report on waste to resource that was more focused on wastewater, and the Wiser tool. And with that, I'll pass it to Clem to present the case of Senegal.
Hello, everyone. Good afternoon and good morning if you're somewhere else in the world like I am. My name is Clémentine Stipp, and I'm a water sector specialist working with the World Bank in the West and Central Africa region with a focus on the Sahel. And today I'll be talking to you about how we applied those Weiser principles that Carlo just presented in Senegal in particular through our collaboration with the government. Sorry, I'm having an issue. Here we go. So first, I'll take you through the upstream analysis that we carried out at the request of the government of Senegal, how it informed our policy dialogue, what existing practices we documented and learned from in order to design investment projects that would scale up circular economy practices already in place in Senegal. So first, a little bit of context about the water sector in Senegal. Senegal is already water stressed. Current water withdrawals are planned to increase by 30 to 60% by 2035. There's a lot of water-related extreme events and pollution, which are costing Senegal over 10% of GDP every year and threatening their ambition to become an emerging country as per their development goals. The Dakar area or Greater Dakar area, that metropolitan area is particularly at risk as it concentrates the majority of Senegal's GDP production and a third of its population. And finally, water security will be a key input for Senegal to achieve its development objectives as per PSE, which is the Plan Sénégal Émergent, the country's main development guiding documents. So the Ministry of Water and Sanitation of Senegal came to the World Bank and requested that we work with them to carry out a water security study to identify what specific challenges the country was facing in terms of water security and how that was impacting or limiting development. You can see on this map the hotspots that were identified for specific water security issues as part of this study in collaboration with the government. We also came up with this framework. It follows the World Bank global water practices focus towards water security on improving water-related services, managing risks, and diversifying water resources. And as you can see, these principles are also very much aligned with the WISER framework. So here are some actions that that we identified specifically in priority for the government of Senegal to focus on through a multi-sector water platform, bringing together different stakeholders from a variety of sectors and looking at different ways to improve wash services, but also irrigation services, working on regulation towards circular economy, improving urban planning and management of extreme events, and finally, actions such as demand management and protection of sources, just like Carlo presented earlier. Some of the specific actions that were also identified as priority to diversify the water sources in the Greater Dakar area included analyzing the recharge potential for treated wastewater to carry out groundwater recharge. So you can see that's this map on the left. Looking at different water transfer scenarios, currently Senegal relies in majority for the water supply of Greater Dakar on water transfers. And so analyzing the different possibilities for other parts of the country as well. And finally, looking at treated wastewater reuse, and those green areas on the right indicate irrigation areas where this treated wastewater could be potentially reused. So as part of this upstream analytical work, we also that also helped feed into some policy dialogue and improving the enabling environment for circular economy, specifically looking at the water and sanitation codes, how the legal framework was structured to promote circular economy, carrying out some dialogue on regulating reuse, specifically for the reuse of biosolids and scaling up the existing pilots, which I'll talk about in a second. Engaging different stakeholders, as I mentioned, bringing them all to the table and reviewing the conclusions and recommendations of this study, which was launched at the World Water Forum, at the last World Water Forum in Dakar. And finally, looking into the development of a circular economy strategy with support from a new investment project from the World Bank. And in order to do this, we also documented a case study, which is on the WISER website that Anna and Carlo talked about, focusing on the Greater Dakar area. As I mentioned, the Greater Dakar area has over 1/3 of the Senegalese population and contributes a majority of the GDP. They also produce 60% of horticulture for export, which is a very big source of income for the country. And they're facing growing water scarcity, but only 28% of the wastewater is treated. So there's a missed opportunity there to leverage that resource. There are some ongoing pilots or ongoing small projects, I should say, for wastewater reuse towards horticulture, specifically in the Niayes area, which has a particular ecosystem that's very prone to growing to this kind of market gardening. But is also facing water shortages because of competition with industry. So today at the Cambérène wastewater treatment plant, which is one of about 5 wastewater treatment plants in the Greater Dakar area, there's 5,700 meter cubes per day that are receiving tertiary treatment, and part of it is sold to private companies for irrigation of green spaces, while several hundreds of those meter cubes per day are sold to market gardeners at a lower price. And this differentiated pricing has allowed this solution to remain affordable for the market gardeners, which has been a positive change for in order to promote this wastewater reuse and this circular economy principle. There's an ongoing Islamic development project increasing that treatment capacity, and the new World Bank project is also working with market gardeners and with the horticulture direction within the government in order to support the institutional capacity and scale up this type of reuse in the area. Another interesting pilot or project, I should say, that is managed by the government of Senegal, specifically through their National Sanitation Office, is the production of energy through biogas capture and use. So in the sanitation sector in Senegal, specifically in Greater Dakar, energy costs represent about 12% of production costs. And 35% of the biogas collected from existing sludge digestion is currently used to generate electricity, which covers 25% of their energy needs. This was developed as a way to reduce energy costs, but the ONAS, the National Sanitation Agency, has actually found that they would like to strive for a net zero, or at least covering all of their energy needs in wastewater treatment plants. And for that purpose, one of the things that they're doing is co-locating all future fecal sludge treatment plants and wastewater treatment plants so that they can maximize the treatment of sludge and the capture of biogas from the digestion process there. Again, this Islamic Development Project is looking to expand this capacity to cover 60% of energy use as part of this goal of total coverage, which would represent about 720,000 savings per year potentially. And finally, the last circular economy reuse-focused measure that is in place in the Greater Dakar area right now is the valorization of fecal sludge as soil amendment. So, of course, this sludge is treated and then sold as soil amendment for green spaces or farmers and flower growers. These are the same clients that are interested in the treated wastewater, but as you can probably imagine, in terms of moving the bags of treated sludge as soil amendments, there's some advantages in terms of trucking those and transporting and distributing that particular soil amendment, as opposed to the infrastructure needed for irrigation through treated wastewater. And so they have a slightly further reach currently, even though the government is right now investing in the treated wastewater infrastructure. The way that this was done by ONAS is actually to include this reuse in the delegation contract for the management of the fecal sludge treatment plant, so involving the private sector to ensure quality control of the product, and also to take care of the marketing. And the soil amendment was then sold at about $1 per kilograms, which does not allow them to reach the profitability threshold, but is developing that market, which can be interesting in terms of promoting circular economy in the future. And again, leveraging the co-location of these of the fecal sludge and wastewater treatment plants. So now I'll talk to you about how all of these different measures are kind of culminating through World Bank support to a new investment project in Senegal, the Senegal Water Security and Sanitation Project, which is currently under preparation. So based on the recommendations of all of this upstream analysis that was carried out, and also the policy dialogue with the government and the existing experiences in Greater Dakar, this project is being designed to promote water security in priority hotspots with a focus on the Greater Dakar area and some other, the Lac de Guerre, which is the main water source for Dakar, as well as the Bassin Arachidier, which is facing a lot of droughts. And the different activities focus on diversifying and developing water resources and water availability, specifically through groundwater recharge, scaling up wastewater reuse, but also helping the government look at different proposals for desalination that are being put forward by the private sector, improving the actual water supply and sanitation services, taking into account the circular economy principles, especially in the treatment area, and reducing losses. focusing on providing irrigation services and making that link between wastewater reuse, groundwater or stormwater capture and recharge and irrigation better in order to increase the number of irrigation campaigns that farmers can carry out. And finally, strengthening citizen engagement to ensure that all of these different circular economy measures really are applied with customers and different stakeholders in mind. With that, I will pass it back to Anna, and I look forward to answering any questions that you have later in the session. Thank you.
Thank you, Clem, so much. As we have seen a very interesting and very holistic example in Senegal. And now we'll hear from Daniel Nolasco, which will present a very interesting case, which is maximizing the use of existing infrastructure, which we think is key for circular economy. It's not only about reuse and recycle, but also making the most of what we already have available. And with that, I'll leave it to you, Daniel.
Thank you, Anna. Just a second. Okay, good morning, good afternoon, and as we could see, good evening as well. I'm going to be talking about an optimization project that we did with support from the World Bank that led to circular economy and decarbonization in a water resource recovery facility, in actually 4 water resource recovery facilities in Sao Paulo, Brazil. And I'd like to pass on to you 3 main ideas. One is that the emissions, the greenhouse gas emissions from the water sector are higher than is generally expected or told. Second, that we need to integrate water and energy system dynamics, particularly in the urban areas, as I'm going to show. And the third one is specifically related to this case study in Sao Paulo, Brazil, where through process optimization and intensification, we achieved circular economy goals, mitigation of greenhouse gas emissions, and also we reduced considerably the capital expenditures and operational costs of these plants. So basically, if I picked this up from the Iowa Department of Natural Resources, and this is distributing the emissions of different greenhouse gases along various sectors: agriculture, residential, commercial, industrial, electricity generation, transportation, and so on. And you can see here waste, 2%. That is actually water, wastewater, and solid waste. And the first thing that calls attention is that, you know, we put all this as they were silos, and we know they're all interconnected. But the second thing is that it is really small, just 2%. And if you pick the water and wastewater, our sector is probably around 1% if you measure only the utility. But I would argue there's a nexus between water and energy, and the emissions beyond the utility not only should be measured, but they can be controlled. And we need to integrate when we get into the urban area with the water, in this case, potable water mostly, and energy that are intertwined. We need to understand how it's used before we generate wastewater and greenhouse gases. And this is something that Dr. Stephen Kenway in Australia did about 10 years ago, a dozen years ago. And they measured this. They measured what happens with energy in the urban area. And this long list here relates to the energy use related to water in an urban area. Down there at the bottom is the energy used in utilities, wastewater and water. And you can see is very, very low, even in average low and high studies in high areas in cities, is still just that part of that 2%. Now, if you look at the energy related to the industrial water use, the commercial water use, the residential water use that is not hot water, and also the residential use of hot water. These are our showers. And this is in Australia that doesn't have a very high use of water per capita. If we move to Latin America, I'm sure this green area here, or this area in general, would be much more. But what the Australians measured is that greenhouse gas emissions are between 5 and 20% of the total greenhouse gases. So it's no longer that 1%. It's probably 10 times higher than expected. And thereby, we need to understand that water energy system dynamics, because that use, the length of our showers are related to the cost of the water and whether we have micrometering in the households or not. And so moving on to the circular economy principles, we have, I think we all know that, we talk about generally about reuse of water. We talk about recycling nutrients, nitrogen and phosphorus is very common. All those point to the reduction of the extraction of natural resources. The same goes when we restore receiving water bodies, or when we recover energy, we're reducing the use of those natural resources and reducing the waste. Okay, but what we are arguing now is that when we look at wastewater facilities, if we reduce the size of those facilities, if we intensify the use of the existing infrastructure, thereby reducing capital expenditures, operational expenditures, we are in fact tapping on the first principle, or I would argue the most important principle of circular economy, which is reduction in this case of infrastructure. And what we have measured in Brazil is that that also leads to reduction in greenhouse gas emissions. And we've done this with support from the World Bank using a Canadian principle of process optimization that we call process audits. And what you see here in this line, we were going to see different unit processes. For those of you that are not familiar with wastewater treatment plants are a series of unit processes that work together. And each of those unit processes, for example, pre-treatment here, will have a treatment capacity, what we call the capacity, how much water it can treat to achieve the purpose of that unit process. And many times we have plants named or designed for a nominal capacity. In this case, for instance, it can be 10 million gallons per day, the plant as it was designed before it was built. But what happens, and we have seen it many times, is that we can do stress testing of these plants, we can do oxygen transfer efficiency testing, we can do mixing studies. And generally what happens is that the actual treatment capacity tends to be higher than that nominal design. And that is good because it means that we have more capacity, or we have the capacity that we need to have. Now, the thing happens when we need to expand the plant because more people are connected, or when we need, in some cases, to have higher effluent quality. But let's talk about expanding the plant because we need more people involved. The common thing to do is just to take that 10 MGD plant into double the whole thing. And if we double the whole plant, this is what's going to happen. Yes, indeed, the capacities are going to go up, but it would have been much more efficient just to increase those processes that represent a bottleneck to achieve that new capacity. So this is the whole concept of process audits, where we avoid all this waste of excess infrastructure, excess CapEx, OpEx, carbon footprint, water footprint, energy footprint, etc. So there are technologies to do this, to measure the actual treatment capacity of each unit processes, to make them more efficient, and to intensify the use of the existing plant. And this is what we did with support from the World Bank in 5 actually wastewater treatment plants in Brazil. And Sabesp is the water utility. And I cannot go through all of them, but just one of these plants, which is a 1.5 cubic meter per second plant that needed to be expanded. And if we had gone through this process of expand proportionally to the nominal design, old design capacity, we needed to move from 1.5 to a new capacity of 4.5 cubic meters per second. To the existing plant here shown in gray, we would have added 2 more trains or 2 more modules if we want. But we actually measured through stress testing and through oxygen transfer testing. We did modeling. We did simulation of future plants. We actually measured the capacity of each of these unit processes. And the result is that we didn't need 3 modules. We just needed 1 more to triple the capacity. We did this for all these plants, for all 5 plants. And I cannot go through details, but the expansion of these 5 plants to a much higher capacity, if we had done it through the conventional wisdom of expanding proportional, it would have cost $548 million. Through the optimized expansion of this intensification, we used considerably less, actually close to $230 million less. The third column here represents expansion to tertiary treatment, which costs considerably more. And the quality of the optimized expansion is somewhat in between conventional and tertiary. So it's much better than conventional, a little bit worse than tertiary at a much lower cost. So that speaks also that we could reuse some of this water. Now, interesting enough, through the process of doing the audits, and this here is the flow rate going into these plants. This is 2019 is when the World Bank started this project. The flow rate improved or increased throughout the audit, the process audits, close to 50%. But look at what happened here with the BOD, or the pollution removed per year in metric tons. This is when we started the project. There's a jump there, an obvious jump, and we increased 60 to 66%. What this means is that actually not only we didn't need to wait until we built all the improvements debottlenecked the plant. There was already things happening as we were studying the facility. Obviously, this needed active participation of the operators. The team was really engaged. We have here engineers from the consulting firm. This is the chief operator of the plant, an engineer as well. These are operators. We all worked together to gather to get information. This is Dr. Diego Rosso from the University of California doing oxygen transfer testing to measure the capacity of the plants. This is part of the team. As you can see, this was COVID time, and this is 2022. But it was a complete success. Now, interesting enough, we decided to measure also greenhouse gas emissions. And these are the emissions from operation in the year 2020. These are for the 5 plants, including scope 1, which is what happens inside the facility, 2, that is related to the energy consumption, and 3, related to what you bring from outside into the facility, chemicals, etc. The projections from, this is not a small emission, it's close to 2 million tons a year, projected to 3 million tons. But here, the increase in effluent quality and the increase in quantity of people served is much higher than this increase. But interesting enough, we measured here the reductions through avoided expansions. So this is the CO2 equivalent emissions eliminated from the reduction of civil construction only. So we measure their demolition, we measure excavation, we measure emissions through concrete and the steel related to that concrete. We did not include equipment. There's a long list of things that could not be included. But if you look at this, if you look at this, it's over 3 million tons. And probably is likely to be twice as much if we had a methodology to measure the emissions related to all the electromechanical equipment that we do not need to put into the plant. So the concept here is that process optimization, circular economy lead to intensification of the use of the plant, and intensification leads as well to greenhouse gas emission reductions, not only in the operation, but also from avoided expansions. This is the reduce that you have at the top as one of the 5 key elements of circular economy. Actually, this is one of the first times that this is published. So in general, emissions from the water sector are higher than expected, and we should think beyond the utility envelope. We need to integrate water and energy system dynamics, and process intensification is good. It leads to circular economy and mitigation of greenhouse gases. Now, one of the questions that Journey closed this presentation with is, why can't we work with a more integral vision of the water sector? Thank you very much.
Thank you, Daniel. Great presentation as you saw. So yeah, we don't have a lot of time for Q&A as it usually happens in these sessions that are only 1 hour. But I would like to get questions from the audience. I think some of them have already been replied, and feel free to say that you want to speak up. You can also connect and ask the question yourself with your microphone if you let me know. And yeah, if there's please any questions. Otherwise, I have questions prepared as well, but we would like to hear from you. So there's a question, last question here from Mayra. The untreated sewage are from the area without sewage coverage or sewage collected and not treated? I don't know to which presentation this was related for, if it was for the presentation of Daniel.
I think it's Daniel's, Anna.
Okay, so the untreated sewage are from the area without. Yes, it's a combination of sewage collected and not treated, and sewage not collected. And basically, this is what Sabespi is trying to reduce. Now they're trying to reach universalization for the whole urban area, which is 25 million people. So it's not a small area by the year 2027.
Okay, I'll see. Another question from Mayra, I guess for you, Daniel. And then I have, do they use the greenhouse gas protocol to measure?
Yes, we use several protocols. We used the California one. We used the IPC. We compared several protocols, but pretty much they're all in the ball. And we used BioWind, which is the simulation software for water resource recovery facilities that also gives you an idea of particularly methane and N2O, nitrous oxide. And the nitrous oxide is hard to model, and there's a lot of aspects that influence that, and it's IPC, in our opinion, is not very strong in order to do that. So we did it with a simulation model calibrated to the plant.
And Anna, if I can add anything here, the UNEF CCC is also has a recognized methodology for the evaluation of greenhouse gas emissions, methane related from wastewater operations. And So I think like since UNEP triple C, and if you're thinking also about carbon markets, this is a recognized basically methodology, right? And this, I guess, also reply to the question on of which one adds, regarding the CO2 emissions. But I think UNEP, I can put a link of the methodology that can be used.
Okay, and I've been told by the Seaway organizers that yeah, we need to disconnect really on time in 4 minutes. So I'll give it to Diego for his concluding remarks. Sorry that there was not as much time as I hoped for discussion. But yeah, you can reach to us. I'll put my email. I think Diego has shared his email. You can reach out to us if you have any question and check the materials on our website. Thank you.
Thank you, Anna, and thanks for all the panelists, and special thanks to all the participants. We had up to 60 people connected, lots of interactions in the chat, which makes obviously, it's a good sign that the topic is of keen interest. I just want to close with a few sort of key observations. Now, the first one is that we've been showing here and throughout the years in which we were working on this design of the formulation of the wiser framework, is that circularity is here and is being endorsed by many utilities and countries and cities around the world, and that we are now, in a stage in which demand has been increasing exponentially from clients to adopt many of these principles, and that we have shown throughout the years and in many cases that it provides an array of different benefits, environmental, social, financial, and economic benefits. It's a way, it makes sense not only for a particular set of benefits, but also for utilities, for example, to lower their capital expenditures and their operational expenditures, for utilities to raise revenues, to improve sort of universal access to water supply and sanitation. And I think Carlo was very clear in the beginning to say that it's a mean to an end. We should not think of circularity as an end in itself, that this is a mean to help us ensure the sustainability of the services with important social and environmental considerations. The other thing that came very clearly, and from the case of Senegal, for example, is the importance of the policy institutions and regulatory frameworks. A lot of the limitations and/or opportunities that we see in the implementation of these investments or programs has to do with limitations that we can have on policies, institutions, or regulations outside the water sector. So limitations that you can have from public health, from environment, from agriculture, for the same energy, on how you treat the energy that is recovered within the water resource recovery facility. So we have to be very much aware, and that it requires a good assessment of these environments, on the policy institutions and regulatory environments, before we embark in implementing and designing some of these projects. The other two critical factors that I think are important to mention here is that first, the role of the sector and the mitigation and Paris alignment. We've seen with Daniel's presentation how critical greenhouse gases and emissions reductions can be when we are preparing these investments and these programs. And we have to make sure that we fully incorporate aspects of mitigation when we design the programs. And the final point that I want to emphasize is also part of the presentation from Daniel, is that we should not forget on the reduce component on circular economy. We should be looking at these investments not only from the point of view of new investments and new programs, but also on how to optimize the existing infrastructure. And as we saw there are significant gains that can be achieved by rehabilitating and optimizing our existing infrastructure. So again, with this, I would like to conclude this session. I thank each one of you for participating, and we hope you can stay engaged. Thank you.